I don't always do videos about theory, but when I do, it's because it's important, so listen up. I want to tell you about KSP, the solubility product constant, and what in the world it actually is. What I want to point out is that when you're dissolving PbI2 solid in water, what's actually happening? You're taking that solid PbI2 and it's dissolving into its ions. You're going to get a lead ion, and the charge on it was +2. It's now dissolved, so we're going to say AQ as well, aqueous. And you're going to get 2 iodide ions. Iodine likes to have a charge of -1, and because it's dissolved, it also gets a little AQ. When PbI2 dissolves, it makes a lead ion and 2 iodides. Piece of cake. What is the KSP, and how does it relate to this, though? What I want to ask you is, write the equilibrium expression for this reaction. What is KEQ? Well, you take products over reactants and you use concentrations. You ignore solids and liquids. Remember that? So, products over reactants. Pb2 plus to the power of 1, because there's no coefficient in front of that, times the concentration of I minus squared, because there's a 2 in front there, divided by the concentration. Oh, no, we don't include this because it's a solid, and solids are not included in the equilibrium expression. Now, for all reactions where you're dissolving a solid, you're always going to ignore the solid. So it's always just the product of the concentrations of the ions you form, including any relevant powers. This is special because it's the equilibrium expression for something dissolving. And that's why, rather than KEQ, we call it KSP, because it's special. Or more accurately, because it's the solubility of the particular chemical. These concentrations are related to how much you can actually dissolve in it. If you put more than this inside a solution, equilibrium is going to shift this way and you'll form solid. If you put some of this in solution, you may shift to the right. You know Le Chatelier's principle? This is just a regular equilibrium. And the deal is that KSP represents the point at which the two are in balance. The point at which you can't dissolve any more PbI2 and you can't form any more ions in solution. Check out one of my other videos for how you can get the actual concentration you're allowed to dissolve from KSP. But for now, all I need you to remember is that KSP is just a regular KEQ for something dissolving. Best of luck!